Then we'll look at how we can plot graph based on the scores we have here. These are the scores of the practicals or the experiment performed in the physics laboratory. We have mass, grams, extension in centimeters. But before we proceed, we want us to look at the graph sheets. If you look at the graph sheets, you have the distance from one point to another, from here to here. This is a centimeter. From here to this thick line to the next thick line, it's a centimeter. So if you look at the whole of this, it's like a square. So from this point to this line is a centimeter, and we'll choose our scale with reference to these centimeters we're talking about. But before we talk about plotting the graph, we need to look at the values. Your values must be properly arranged. If you look at these values, the units of extension is here, written here at the top. You can now come and write 1.40 cm. The units are always at the top. This is mass in grams, and the unit is at the top. And if you look at this course, we have maintained a uniform number of decimals, 2 decimal places. It's not like you come and say 1.4 here, 1.75. The number of decimals should be uniform. That is a proper thing to do. And by the time you look at this, you look at the range of your values. The smallest value here is 10 grams, and the highest is 70 grams. So that if you are choosing a scale, or maybe 2 cm represents 10 grams, you should choose it in such a way that you don't have difficulty. Look at it here. We have the smallest number as 1.40, and we have 3.90. Let's look at the range. It's not much. Another thing we need to know is that in plotting the graph you have plotted should occupy more than half of the graph sheet. The graph you plotted should occupy more than half of the graph sheet. So, and what will determine that is your scale. The scale you have chosen will determine the size of your graph. So, the first thing to do here is to label your axis. We are plotting mass in grams against extension. So it means that mass will be on the y-axis, while extension will be on the horizontal axis. But the mass we are plotting is in grams. So what we need to do is that on the y-axis we have m in grams. Or that you come and write y-axis. We know that this y-axis, but what is being plotted here is mass. And then on this axis is extension in cm. This are the axis. You have labeled your axis. And then the next thing is the title of the graph. The title of the graph. And what is the title of the graph? You can say the graph of m in grams against E as the extension in cm. It's boldly written there. The graph of m in grams against extension. So that anybody looking at your graph we know that this is what we have plotted on this axis and this axis. And the next thing is scale. You need to choose a scale, and your scale will be written there. So on the m-axis, looking at the range of values here, we can choose the 2 cm represent 10 grams. This is the origin. So from here, this is 1 cm, this is 2 cm. So we can say 10 grams, 20 grams, 30 grams, 40 grams, 50 grams, 60 grams, and 70 grams. You can see that the graph, my scale, is in such a way that the graph is more than half of this graph sheet. So I can say that boldly written here, 2 cm represent 10 grams on m axis. 2 cm represent 10 grams on m axis. Then what of the e axis? Look at, we have this 1 cm, 2 cm. So we can say that 2 cm represent 1 cm. So this is 1, 2, 3, 4, 5. It's 1.0, 2.0, 3.0, 4.0, 5.0. So we now plot our values. The first value is 10 against 1.4. This is 10. This is 1. If this is 1, there should be 1.5. So 1.4 should be here. You mark your value there. The next one is 20 against 1.75. On the m-axis is 20. This is 1.5. This is 1.5. This is 1.6. This is 1.7. And 5 will be at the middle. Next is 30, 2.15. It's 30. And when you look at this, this is 2. This is 2.1. It's not up to 2.2. So it should be between 1 and 2. That is 2.15. The next one is 40. 40 is 2.60. This is 40. This is 2.5. And this is 2.6. So you carefully mark it there. Then the next is 50. 50 against 3.05. This is 50. This is 3. It's not up to 3.1. 0.5 should be somewhere in between. Then 60. 60 against 3.5. This is 3.5. This is 3.5. So carefully mark it here. Then the last one is 70 against 3.9. This is 3.5. Is 3.5. But what we have is 3.9 is less, 1 less by 4. So this should be, this is 4. So 9 should be here. So we have plotted the graph. So we now used your ruler to join. There's what we call the best line of fit. Most of the times we have 1, 2, 3, 4, 5, 6, 7. We have 7 points here. It's not possible that all of them would be on the straight line. There's what we call best line of fits. In drawing your best line of fits, you draw in such a way that some will be on the straight line, some will be by your left hand side, some will be by the right hand side, and that will give you the best line of fit. But if you want to struggle in such a way that all of them should be on the same, on that best line of fits, it's not always possible. So there are certain questions that will follow. Sometimes they will ask you to find the intercepts. Sometimes they will ask you to find the slope of the graph. So depending on the questions that are being asked, or that the question that is asked, then you can approach it with confidence.